Hello, everyone, and welcome to the CGC's webinar on cytogenetic laboratory automation, implementation benefits, and roundtable discussion. It's my pleasure to be your moderator today. My name is Dr. Adam Smith, and I'm going to be doing a brief introduction and making a few notes just before we start our presentation with Drs. Nanette Cohen, Cecilia Miller, and Jenny Thurston. So allow me just to show you a few slides here. So one important note, the CGC annual meeting coming up in St. Louis, August 4th to 7th at the Hyatt Regency. Early registration ends tonight on May 21st. So be sure if you're planning to register that you get your registration in today. Also, I wanted to very briefly talk about cytogenetic laboratory automation. And so this is actually, this is a webinar series. It was a webinar series proposed by Dr. Adrian Dubuc. And we are very pleased to be able to bring this to you. And this is actually going to be a series of webinars because we think there's actually a lot to talk about. And we didn't want to have a very, very rushed discussion trying to sort of summarize everything, but really get into a little bit more detail about what's actually happening. So, general cytogenetic process here. And I just wanted to show in these different lines here, sort of some of the different areas where we can do some level of automation. And so we're going to be basically looking more sort of at harvesting automation, slide making, and auto scanning, metaphase finding today. But we will be having other sessions, so just stay tuned to your email for that so you can see that coming up. Okay, let me at this point in time take a moment to introduce very briefly our panelists and who are going to lead the discussion today for this session. I remind everybody that in order to have interaction, we do want you to use the Q&A tab when you're not the chat tab. So the Q&A tab is where you need to put your questions in if you want to interact with the session. And sorry, just before we move on, we do have a poll to run here before we get started. So I'm just going to ask Emily to start the poll and have everybody put their answers in. We're going to give you about 20 to 30 seconds here to put your answers in. We're just going to wait another 10 seconds or so for everybody to put their answers in. Okay, great. I think that's it. So we can share those results. So it looks like, we have a good percentage of people in the audience that have already implemented automation technology in the lab for this first session. So harvesters, about 50%, slide dropping, about 36%, scanner either for fish or karyotype. And I think, again, this is one of the most important go-to tools we use, that automated slide scanning for metaphase finding. And a lot of labs use those. And automated counting or semi-automated counting for fish at 20% roughly. So that's great information to have going into this session. So hopefully there'll be some good discussion moving forward to help everybody think about other types of automation. Okay, so moving on. There we go. Okay, by way of a brief introduction, I'm going to just read a very short biographical blurb for each of our panelists today. So starting with Dr. Nanette Cohen, she's the Senior Director of the Division of Cytogenetics, Molecular Pathology, and Prenatal Screening Labs. The Department of Pathology at Northwell Labs, Northwell Health, is New York's largest healthcare provider. Dr. Cohen has been a part of Northwell Labs' leadership team since 2017, overseeing the clinical and academic activities of the genetics labs at North Shore University Hospital and Long Island Jewish Medical Center. So we'd like to thank Nanette for joining us today. In addition, we have Cecilia. Welcome, Nanette. Thank you. In addition, we have Cecilia Miller, who's an assistant professor in the Department of Pathology at The Ohio State University. She serves as division director of the Cytogenetics Laboratory at the James Comprehensive Cancer Center, and Dr. Miller is a board-certified clinical cytogeneticist and molecular geneticist as well. Welcome, Cecilia. Our final panelist is Dr. Jenny Thurston. She's the Senior Director of Cytogenetics and Co-Director of Molecular Pathology for the Carolinas Pathology Group in Charlotte, North Carolina. Her primary professional responsibility is leading the core cytogenetics laboratory for Atrium Health, a comprehensive cytogenetics laboratory providing testing services in genetics and oncology to support a 50-plus hospital integrated health network in the southeastern United States. Jenny, thanks so much for joining us, and I think that's everybody introduced. So we're going to move on. And I'm going to just, there's one sort of speaker disclosure here, and then we're moving on to the cytogenetics laboratory workflow. And I'm going to turn things over to Nanette here for a brief introduction.
First of all, I'd like to thank you and the CGC for giving us the opportunity to have this panel because it is very important. Can I have the next slide, please? As Adam mentioned, I work for Northwell Health, which is the largest healthcare system in New York with over 90,000 employees. We do have 2 cytogenetic laboratories, and we service the entire healthcare system of 23 hospitals, New York City health and hospital systems, and outreach clients. We offer testing, as you can see here, both constitutional, prenatal and postnatal, and hemato-oncology, oncology, neoplastic. And in these slides, you can see the number of employees we have in both laboratories, and our annual volumes for chromosomes and fish per specimen type for 2023. Next slide. We have acquired automated equipment for these 3 stages of the workflow for harvesting, dropping, and slide scanning. And next slide. And for each laboratory, we have on the left, you see this is our larger volume cytogenetics lab. We have those 4 equipment, and in our smaller lab, we have those 3 equipment. Thank you. I can't hear you.
You're on mute.
Sorry about that. Okay, so stopping sharing the slides so we can now move out and have this discussion, and we can talk about all of the issues regarding the benefits, limitations, implementation challenges, etc. And that's our general theme for this afternoon. So at this point, I'd also like to give both Jenny and Cecilia an opportunity to talk about their environments, and then we'll get into some more discussion. So Jenny, if you'd like to start just giving us a little introduction to your environment and the automation in your lab as well.
Sure. First off, thank you for having us. We're all pretty excited to be on this panel, and I'm looking forward to some good discussion. I've been in the field 25 years, which floors me every time I think about it. In the past, I've worked in a large academic lab. I set up a cytogenetics lab in a medium-sized healthcare system, and now I work here at Atrium Health, which is a large hospital system. I think we have over 60 hospitals in the system, and we recently merged with Wake Forest University and with Advocate in the Midwest. And those each have their own cytogenetics lab. So I'm just going to talk about the one here in Charlotte. We do about 8,000 tests a year, have about 12 technologists, and at some point I've been involved in implementing or being part of implementing slide stainers, chromosome dropping, chromosome scanning, fish dropping, fish probing, and fish scanning. So I'm really looking forward to seeing what other labs are doing.
Great.
Thanks.
And Cecilia, if you can sort of just round out the discussion with your experience, and also I think right from that you can just transition right into the discussion about your implementation with harvesting automation.
Sure, Adam. Thanks to you and the other organizers for putting this webinar together today. So here at Ohio State, we're an academic laboratory. We're specialized in oncology cytogenetics. So the predominance of the sample types we're receiving are blood and bone marrow from patients with hematologic malignancies. Annually, we perform approximately 4,000 conventional chromosome studies, and about 14,000 FISH probe sets are analyzed. So we've tested automation all throughout wet lab processes. In regards to the slide you showed earlier, we've implemented automation in harvesting, banding, metaphase slide scanning. Our scanner is linked to AI-assisted karyotyping software, case data management software, and our LIS. So our conventional chromosome testing is paperless, and some portions of our report is automatically generated. In FISH, we have automation for cell separation. We use multi-weld FISH slides, which are processed using equipment that does the denaturing, hybridizing, and FISH washing. We do have FISH scanning in the lab, but the technology is still being validated. So I think your next question was about harvesting, right?
Yeah, let's go right back to the. I noticed, in fact, there is a question in the Q&A which it was, which piece of equipment did you bring in first and why? So let's just keep that question in the back of our minds for now, because I think sometimes the first piece of equipment we bring in isn't always a rational decision. It's sometimes it's just whatever gets approved by the capital equipment process. So yeah, but I think that's a worthy discussion we can have after that as well. But yeah, let's first talk about the harvester and the limitations and implementation challenges.
Sure. So the harvester here at OSU, it was actually brought in when I was a fellow, so I got to work on some of that validation at the time. I think a primary consideration for getting one is decreasing hands-on time in the wet lab. The more you can get the techs out of the wet lab, the more time they can spend on analysis. I think a secondary consideration for a harvester is, reducing the variability in your processes. If you can put it on an instrument, that instrument is going to do it exactly the same every time. So I think those are the main reasons for bringing in that piece of equipment.
And can you speak a little bit to the process of validation? And I've heard some labs have said, like for constitutional bloods, it was very straightforward, but for marrows, it was a little bit trickier to get the process, or if you've had any experience in that regard.
Yeah, so we put both our, everything here is oncology. The bloods and the bone marrows go on together. Many settings can be adjusted on the harvester, so there was a lot of time spent dialing in, the exact settings to use to get it most comparable to the hand harvest. It wasn't necessarily that, your times are going to be exactly the same, because if you're doing something by hand, you may say 5 minutes, but maybe you're moving the tube from a centrifuge back and forth, and really it's 7 minutes. So you kind of have to do a number of test cases to work through that and get it to where you like it.
Sure.
We aren't able to put every sample type on the instrument. So that's, one limitation. Particularly, we do get bone cores. Those can't go on. The other big thing is that if the specimen has any clotting, it can't go on the harvester, and they need to be flagged so we don't accidentally put it on there.
Right. And what do you feel in terms of the time that it took you? And yeah, I mean, you can give this, you could say the real time it took us to validate, and if we sort of known maybe a little bit more when we started, we could have probably got that validation time down to something more compact or something like that. Just I think I want to estimate the amount of validation time that it took to actually get this off the ground.
You know, I don't have the best answer for that. I think months and months is part of it.
Yeah.
But, you know, I think part of the issue with validating anything is you're trying to do it as you're also doing all this other workflow. You get staffing issues. So I think it dragged on a little bit, but, you know, maybe if we're getting a second harvester and I can say I'm not really worried about validating the second one because we're going to go with putting in the same settings that we have for the first one and then sort of tweaking from there. So maybe, you know, it would be helpful to speak to other labs if you have a particular model you're going to get and start there with kind of dialing in your settings if you know they're using the particular sample types that you're wanting to put on the instrument.
And I think this is it's just an important consideration with any of these automation technologies. They're not plug and play for the most part. They do require really, bringing them in, testing them, getting the settings right, dialing it in. And so I think with that, we'll move to Nanette as well and ask similar.
Can you hear me? Can you hear me?
Yes, go ahead. I think Adam's webcam just.
Oh, okay. So I personally have experience. I've been working with the automated harvester for over 10 years. So in my previous job, we acquired one almost overnight because the volumes of constitutional bloods was exploding and we couldn't handle it. So we validated pretty fast because we didn't really have, when I say fast, probably less than a month. We didn't have an option. At Northwell, we have two systems, one in each lab. We use it both for constitutional bloods and for bone marrows and for oncology bloods. And we have also validated to put products of conception because our volumes are very high. And it was almost ridiculous to have our technologists just stand with hundreds of POCs changing figs and having to even smell all that. So we validated that, and I'm happy to share our experience if anyone wants to try to harvest POCs. And the results are pretty good, they're consistent. Again, the main reason why we all bring harvester in is because the caseload, there is tech shortage. For me, it's also trying to eliminate exposure to acetic acid. So at least the techs don't have to breathe that as much. And I think that's our experience with the harvesters. We love them. I have no idea how we did it without them before.
Thank you. Sorry, I'm gonna step in. I'm Celestino. I think Adam's webcam went out. So Nanette, how did for the return on investment, what were you seeing as your major return on investment?
So when we did the justifications, we calculated minutes, hours, and it came out that if you do a manual harvest of a certain number of tubes, it takes about 2.5 to 3 hours. And we calculated, how many techs do you need to do all of that? And the machine doesn't do it faster, but the machine does it. So we utilize our techs to either cross-train them, do something else. When the samples are coming, they can set them faster. So there was a big return in investment.
And was there a point either for Cecilia or Nanette that your number of samples made you go to a harvester, or was it that was it solely because of just tech time in general?
I think for us it was both. Again, in my previous laboratory, we had explosion of the number of constitutional bloods were just pouring from fertility clinics. It was impossible to catch up. So, but in these laboratories, it's plus the volumes, plus there's shortage of text. Also, you don't get a position every time you ask for a position. So sometimes if an employee resigns or quits, whatever, you don't always get the replacement right away. Plus the shortages that you can't find somebody right away. So
It is easier for training purposes.
absolutely.
Great. Cecilia, did you, or sorry, Jenny, did you have anything else you wanted to add to that?
So we weren't talking to me. I don't have a harvester. I'd love to
Okay.
get one.
Okay. Well, that's good.
Missed that part.
Yeah, I mean, I think one of the big considerations is also the volume has to be there for the harvester to make a lot of sense sometimes. And I don't know if either of you, either Cecilia or Nanette, have any feelings about volume thresholds for moving to harvesting, if it below a certain volume, if it makes sense or not, in terms of the amount of time. I don't know if that's something that you considered when you made that transition to the harvester.
At Northwell, the volumes were always high, and they keep going they keep increasing because the health system is just growing. And we see the volumes are just coming. I think there was a question, you want me to speak about the POCs? I saw, what was the question? Because it went.
The question is more specific. So on the products of conception, automated harvesting, which harvester did you validate for that?
So we do have the Hanabi, that's the only harvester I've ever used in my life. And we tweaked the protocol until we like the result. And again, we're happy to share protocols. If anyone needs, can contact me directly. And then you can adjust or tweak. But it's been extremely helpful for us.
Okay.
Yeah, Adam, in relation to your volume question, harvesters come with different capacities. For us, we have a medium-sized one with the notion that we split, basically do 2 runs a day, right? So we get culture 1 goes in first, and then when that run's complete, then culture 2 goes in. So that's one thing you can consider if you're looking at capacity, what you need.
And a redundancy, do you have one harvester or 2 harvesters? How do you?
So we have 1 harvester for every lab.
Okay.
It would be very hard to get a second one. Plus, we're very tight in space. We wouldn't even have where to put it. So.
But it sounds like to me then that the instrument, you consider the instrument to be robust. It doesn't have a lot of mechanical issues.
In general, no. And I believe we run it at least twice a day. One for the oncology, one for the POC. It depends, if the cells are ready to be harvested. But we do a lot of runs.
We have one, we are getting a second one for that redundancy when we move and have more space.
There was just coming back to the POC question. There was the question from the Q&A that is POCs in 15 milliliter tubes.
Yes. So what we do, we have the flask. We grow them on regular, the small flask, the T12.5 flasks. And when they're ready, we trypsinize, we move them into the 15 ml tubes, and we process them as liquid cultures.
Okay. We have another question in the Q&A actually, that I think it's interesting. It's relevant not just to harvesting. I think it's relevant to all the areas of automation that we're going to discuss, but I think we can just introduce it now anyways. So the question is, when you're interested in bringing in automation, how do you start determining which company do you select? How much time do you dedicate towards researching your options? So I think this is this is the challenging question, obviously, because it can be, 15 minutes. The guy knocked on my door and then we went ahead, or it can actually be a very, thorough process looking at all of the features. But I'd love to hear from the panelists' experience, what they think about this.
I can go first if you want. We see vendors at conferences. We speak with colleagues, but they have experience with certain equipment. I think speaking with colleagues is the best.
Yeah.
Because you get direct information and true information in most cases from other users. And I would trust that more than anything else.
Totally agree. If you can talk to somebody that's
Yeah.
utilizing it, it's so helpful. You can learn pitfalls and things that might not come out otherwise.
Yeah. Plus, we have offered, like, whenever anyone may call for a question or if they want, we offer that if they want to send us pellets or if they want to bring their specimens over, I mean, if they're in the area around us, we're welcome to, that they can come and try and see it on site and speak to our techs and see real time how it works. So we had, I believe, 1 or 2 laboratories for them from the New York area that they visited just to see how it's the workflow.
Yeah, I think this is, I mean, I think this is great, and it's of critical importance, you know, when we're all reinventing the wheel oftentimes in a lot of these scenarios. So there was another question here, which I think I know the answer to already, but does automated harvesting give better quality than manual harvesting? I don't know, Nanette, Cecilia, your thoughts on that question?
I think it's comparable most of the time, sometimes sample dependent. You know, it again comes back to if you're comparing to manual harvest, the experience of the tech that did the manual harvest.
I can comment for prenatal, which we don't have a prenatal harvester here, but in my previous laboratory, we also had a TCAN. I have to tell you, a manual harvest of cover slips, it's superior to the TCAN. However, if you have 50 slides a day, it's almost impossible to have a manual harvest every day, especially with prenatals that everybody wants the results right away. So if your volume is large, it's probably worth it having a TCAN and compromising a little bit on the quality. But if you don't have a lot, the manual harvest is, again, for in situ cultures for amnios and CVSs. I think for peripheral bloods, bone marrows, and all the oncology, even POCs, it's comparable. And the truth is that with these volumes, we wouldn't be able to do all this work.
Okay, great. Okay, well, I think that was a really great discussion on the harvesting, and in the interest of time, we definitely want to move on to slide dropping technology. So I think in that regard, we're gonna start off speaking with Nanette, because I believe you have experience with 2 platforms, Nanette, and you can sort of just give us a little bit of an overview about, you know, how you're using slide dropping and your experience with bringing that into the lab.
Okay, so about 3 years ago, we decided that we needed to bring in our North Shore laboratory, which is the larger volume and more staff laboratory, a dropper, because again, the temperatures and the humidities, and some people are so good in dropping slides and others are not. And we said that it is the time to start to introduce that. It took us a while. We tried, I believe, 2 systems, and I think it was 2. And then we decided to go with a company that also has an option to do fish, because our fish volumes are also, and also that equipment, it can accommodate a larger volume of specimens. And that was, we did a lot of trials. And the way we work in our laboratories, we try to make the final decision based on our tech's response. If our technologists say, we like this quality or we don't like this quality, we take their word. Of course, the directors and supervisors and managers, we all look at the whole picture. But ultimately, it's the technologists who read the chromosomes. And if they tell us they're not good, the others were sharper images or whatever, then we listen to them. they have a voice in our laboratories. The smaller lab at LIJ, we decided to go with a different company, which is a smaller equipment, and we use it for constitutional bloods. It's only liquid, and bone marrow. We have very small amount of bone marrows in that lab. It's only pediatric oncology. And our fish volume there is extremely small compared to the other labs. So it didn't really make any sense to bring a very large equipment that also has a capability for fish that we wouldn't use it. So based on these two parameters, we decide to go with one platform and another.
Sorry, were they different companies, those two platforms?
They're two different companies.
Okay. Okay. Cecilia, did you have any comments that you wanted to make about that?
Yeah, dropping's one area, you know, we tested that in the lab. We never found a solution that completely worked with our workflow. For chromosomes, we're in Ohio, so the weather is quite variable. We have huge swings in humidity that presented an issue to us that it was hard to get a dropper equilibrated. And on the fish side, you know, we have struggles. We have a lot of different fish probe manufacturers. So dialing in settings that would work given our variability, we just didn't get where we needed to be with it, that we felt like we were seeing a benefit compared to doing it by hand.
But you are using it for dropping slides for karyotyping?
We don't use it for either at this point. Yeah, we've tested for both, but decided that we just couldn't find a solution that worked for our workflows.
And in terms of the fish dropping, anybody can comment on this. Just wanted to know about the volume reduction. So is that, I don't know if, I mean, this is sort of one of the things that is used as a selling point, is that you can do significant volume reduction in probe, which leads to significant cost savings. And I'm gonna do a sneaky thing here, and I'm gonna tack on one of the Q&A questions, which is gonna make the whole answer much more complicated. So with the incoming new regulations from the FDA, once we start moving volumes away from, so if you have an FDA regulated probe, if you move away from the volume that's in your insert, you're now, you know, talking about an LDT. So how does that potentially affect us in the future as well with this automation technology? So you can answer the first part and not answer the second part if you want.
So I'll start with the droppers and wait on the FDA just yet. So we actually had great success with the dropper that we ended up using. We use it for dropping chromosome spreads, for dropping for fish, and for probing. So it does all three. And I will say, we kind of had the perfect storm because we were looking to move to multi-well plate slides. We were looking to use, change the vendors of the fish probes to a less expensive vendor, and we're able to work with the fish vendor and the dropper vendor to come up with great cost savings if we went that route, and was able to convince our administration that this would be ideal, particularly with the reduction in the fish probe volume. It also is a barcode reader, and it works with our LIS system as well. So it has cut down on the potential for sample swaps or putting the raw probe on. So that's been a great help as well. The thing that I didn't anticipate was COVID, because when COVID happened, and of course there were the supply chain issues, the 15 mil conical tube manufacturers changed. And when that happened, you have to adjust the height of the pipette tip to remove sample and add probe. And we've had times where it wouldn't reach it, and times where it has gone through and hit the bottom of the tube. And actually that's happening today in the lab. Our sub for the 15 mil conical tubes does not fit as well as it should. So we're adjusting the height of the pipette tips. And everything is an LTD in the lab here. So I'm hoping we're going to get grandfathered in when they figure out what they're going to do.
Yeah, I was gonna say, do it now and do it quick.
Exactly. Trying to validate everything. And that was the other thing. We validated all three, the multi-well slides, the new fish probes, and the piece of equipment all at once.
Okay, any other comments from the rest of the panelists about that or about the FDA comment?
We are currently validating the fish function of our dropper. It's been taking us a little longer than we thought. We focus first on the chromosomes. So as we speak, we're validating, and hopefully it will not take, again, like I think Cecilia said, we don't have R&D teams. All of this is happening while clinical work has to be signed out, processed and signed out. So we offer overtime, we try to squeeze more things in the day, but it is very difficult to validate.
That's great. Okay. I was going to ask just briefly, there was a question in the Q&A that came up about the slide dropper vendors, if you're willing to share which slide droppers you're actually using.
So we use the Scorpion and the Cytogenetic multi-well slides.
And we use, for the larger volume laboratory, we use the Biodot, and for the smaller volume laboratory, the smaller one is Hanabi dropper. Adam, you're muted.
Sorry, we have a bunch more questions, and I want to keep moving on in the interest of time. And a couple of these questions I think are more general, so I'm going to save some of them more towards the end, but I would like to move on because we did want to talk a little bit about the slide dropping for G-banding, which I think we've talked a little bit about during these questions already, but I wanted to take a moment just to focus on that. And then so we're going to ask both Jenny and Cecilia to comment on the slide dropping for karyotyping. And then that's going to lead us into sort of a transition into just the scanner. I think the scanner technology is probably, at least for karyotyping, one of the most well-adopted automation techniques that most labs are using, at least based on the survey. And then we can also touch briefly on fish semi-automated scoring. So with that, let me turn it back over to Jenny for the slide dropping and G-banding.
So that was one of the first things that we did, was try it and see if it would work with G-bands. We dropped both our constitutional bloods and our bone marrows on using the dropper and get very good success, I think. Every once in a while, we'll have to drop by hand. Today, we're dropping by hand because of the issues that we're currently having adjusting the tip height. But in general, we pretty much drop everything using the Scorpion.
Okay, great. And Cecilia?
Yeah, we drop everything by hand at this point. But if you were curious about banding, we do have automated banding for all the slides. So, you know, that was something that, again, increasing throughput. So it can process a lot more slides than a person trying to move them through by hand, and decreasing that variability in the process are reasons for getting an automated stainer.
Yeah, we had an automated stainer at one of the previous places where I worked. It worked really well. It was a lot of trial and error, trying to get the consistency. And of course, could any of us agree on what was good quality for staining? And that took longer than anything else. But eventually we were able to dial it in and got good results, I think, and I'm trying to get it here as well.
I think it definitely fits that category, like Nanette was saying earlier with POCs of you get most of them looking good. You know, there may be that one-off case that, you know, you would have dialed it in if you were doing manual, but the throughput kind of outweighs that.
Also, I would like to add that when we use the droppers for the vast majority of our cases. And what we noticed, and the reason we like them and we wanted them, it's because the banding is homogeneous, because everything is dropped in the controlled conditions. So that's one of the pluses, is the downstream after the dropper.
Okay, great. There was a question here about durability of the tubing and other parts of the instruments with the constant exposure to fix and other inorganic solvents. Organic solvents. So does anybody have any comment in terms of I guess just general durability of the instruments and part replacements? You're all using a lot of these instruments very frequently. So just to comment sort of on the maintenance schedules and what needs to be done to keep them running at peak performance.
We've had ours for about 5 or 6 years, and I think we've only replaced the tubing once in that time. And we use it twice a day, every day.
Nanette?
So ours, it depends on the equipment. The harvesters, I don't think they've given, through the 10 years I've known them, rarely there's an issue. And of course, there's regular maintenance. The droppers is a little different, I think, because one of them is more complicated or sophisticated equipment. It tends to break a little more often, but the support is pretty good. So we try to troubleshoot. And the other equipment, it seems to be fine. So I'm not sure about erosion and all. I don't know the details, but in general, they operate okay.
Okay, great. Cecilia, any additional comments to that?
Yeah, I'd say for us, the harvester and the stainer, we've not had any really major issues, maybe once or twice on the harvester, but again, that instrument has been here for years. When we had a dropper for chromosomes, we did actually have a number of maintenance issues. Basically, the biggest issue was that the compressor would need replaced fairly often, just because it was always trying to overcome our wild variations in humidity. So that piece failed multiple times.
Okay, good. Again, there was a question about the manufacturers for the droppers, but I think we're still talking about the same instrumentation. So BioView and Scorpion. Is anybody using any other droppers other than those?
Not BioView, it's BioDot, and it's also Hanabi dropper.
The Hanabi dropper as well. Okay. So, and does TCAN have a dropper as well?
I don't know. I know they have in situ harvesting for the cover clips. I don't know.
Okay. So that's everybody out there in the webinar's homework. Okay, you have to go and find out now. Okay, great.
Adam, I would like to add that when we do drop manually, we drop everything in a thermotron.
Right.
So at least in one of the laboratories. In the other, we drop in the air, and then they put it in a container that has temperature and humidity to dryer.
Right. Okay. Okay, great. We want to move on, cover a few additional points just before we run out of time. So I wanted to move on to scanning technology, and I think this is probably the most used of the automation technology. So I think we can probably pretty quickly go through this. I think most people are probably using metaphase scanning as sort of a must, as sort of go-to technology in cytogenetics lab. It really just takes techs off the microscope scanning for metaphases and puts them, you know, at metaphases doing analysis instead of wasting all that time trying to find them. So I think we can probably just very briefly touch on that point. And then if we want to move to anybody that's had experience, I think perhaps Jenny and Cecilia, if either of you wanted to touch on using them for semi-automated scoring by fish, that would be the second point. So I'm gonna turn things over to Cecilia now just to talk about that, and maybe you can do those two parts together.
Yeah, so this lab has been scanning for a long time. We actually have recently switched instrumentation. The old instrumentation was being sunset. So it was an opportunity to try to find a single solution that would get us both capturing metaphases, moving into fish scanning, and we were very interested in having a software package that we could do case data management and try to move towards paperless. So we really took on a big load with making that shift in the lab. I would say for us, for scanning, we were looking for something that we could literally, the tech loads it and walks away. You don't have to babysit it any. You're not having to pick what metaphases you want captured at a higher magnification. So, you know, that took some time to dial in and a lot of working back and forth. The other thing that has saved us a lot of time with scanning is integrating it with the LIS. So you're not having to sit there and type out all of your patient information. If you can read a barcode, that's a huge gain as well. Fish wise, we're just getting started, and it's been a big shift. Techs have to get used to, you know, software that they've not previously used. You have to dial in for all of your various probe types, how you want the scans captured, how much Z-stack you want, how many cells you're going to capture for each probe. So it's been a bit of a slog to get that one up and running.
Great. Okay.
But we're getting
Jenny?
there. We're making progress.
Yeah, it's not this is the experience. I think the universal experience is that most of this stuff takes a lot of time and hard-won effort to really make the gains worthwhile in the lab. So sorry, I won't speak anymore. I'll let Jenny tell us about her experience.
So we started off with the G-banded chromosome slide scanner. It did very well. We use it, run it at night, so the techs have something to look at in the morning when they come in. I saw a question somebody asked, how did the technologists react? I will say the more experienced technologists did not want to look at the chromosomes on the computer. They wanted to look at them on the scope. The less experienced technologists who are more used to working on the computers loved it. So it took a little while to be adopted by everybody, but in the end, it worked out really well. I will say, if you're thinking about getting a scanner, keep in mind that you have to get the scanner that's associated with the analysis software you're using. You can't use one analysis software to run someone else's scanner. I've looked into that. So keep that in mind. If you're thinking about changing your software, you'll have to change the scanner too. Like Cecilia said, the barcode reading, it's been great. We're completely paperless, and the Epic reads the barcode, puts the patient demographics, put the probe maps on there. It reads everything, creates the cases, and we're good to go. We then added on the fish, and that's been a little more challenging than the G-bands. We did get it validated. Part of the problem is if there are few cells, if it's a sample that has a low white count, the scanner spends a lot of time looking all over the cell for the well for the cells, and it can bleach out the signal. So we're kind of selective as to which samples we put on there. And of course, if it's a stat PML, it's much easier to look at the scope than to run it on the scanner. But the way we have it set up, the scanner does a first pass, does the analysis, and then we have two technologists that go back and look at all the images and reclassify. So we're not to the point where the scanner does all the work for the fish analysis.
Okay, great. That's great. Question from the Q&A. Do you use separate protocols for constitutional and oncology for automated slide making?
For the slide dropping, yes, we do. We also have different, for the scanning and the analysis, we have different protocols for the oncology versus the constitutional. And then we even set up the number of cells that are captured much higher if it's like a COG sample. We run those as well. So we capture a lot more cells with them.
Great. I guess, I mean, and this is also a consideration too about the way that the FishPro validations, the way you design them, because if you just design your FishPro validations for 200 nuclei, you can't use the same cutoffs for 300 nuclei or 500 nuclei. You have to be able to set them as scalable, which is probably a whole other webinar that we should plan to talk about, because there's no time today. So anyways, actually, and scanning through the Q&A, there are a lot of open questions. So I do want to move. So we have two things we need to do. We need to do a few more questions from the Q&A, and we need to do the poll. And what I think I'd like to do is I'd like to do the poll really quickly. We'll answer a few more questions, and then we're going to close out. We'll try to close out on time. So I think that's what I'd like to do right now. So we've got our second poll that's open right now. And this is: what automation, based on your experience today, are you thinking about incorporating in the future, or just from your experience in general? So we'll give everybody a little bit of time to answer that question. All right. Here we go. Okay. So a lot of interest in harvesting and slide dropping, and really a lot of interest in automated counting, fish and metaphase prep. It's at about 60%. That's the winner, I guess. If we're going to call a winner today, then and I think, interestingly enough, I think if we remember back to the survey that we opened with, this is probably one of the areas that had the least implementation. So anyways, and it was very nice to see how people are feeling in the community in general. Okay, we have a couple minutes left to answer a few questions. So I'm going to try and get through a bunch of questions. There are a bunch of questions on the FDA, and I'm not really sure that we're really well prepared to answer these questions. I think that maybe as there's more clarity moving forward, this is a topic that the CGC should maybe approach in another webinar. So I'm gonna skip the FDA questions, not because they're not good questions. They're very good questions. We're just not prepared to answer them today, I don't think. So we're gonna move on to that. We're gonna move on for that. Okay. So I think, let me just see here. There's a question about maintaining staff competency once you move all of this work to automated processes. How do you deal with maintaining staff competency for downtime procedures and manual procedures when you need to do them? Is there anything special you do, or you just keep making sure people are always trained, or do you have a core group of people that are trained? Do you train everybody? Like, how does that work in your individual centers?
I believe we train everyone to do also manual harvest and manual drops. it is an issue, because if they don't do it occasionally, then you can lose the skill. And that's a good point. Maybe we should go back and make sure that we do that.
That's a great question. As here today, we have some newer technologists that have never dropped by hand. So we're having the more experienced ones show them how to do it. And even the more experienced ones have not dropped the way I have dropped in the past when I was trained. So I think that's a great question. Everybody is trained to cover every aspect of the lab here. But the newer ones, and the ones I'm talking about, have a year or less of experience. That's something that we are starting to incorporate into their training.
Cecilia?
Yeah, I think for us, in many cases it works out okay in that we get certain sample types that, like for harvesting, that wouldn't go on the harvester. We also do a number of directs, so people are continuing to, we still do those manually, since we only have the one harvester. So we have opportunities there. We do 6-month comparability too, where people have the opportunity for hands-on time.
Great. Yeah, I can attest to the fact that we used to have we had a person in the lab that used to be the person who did the dropping because she made the best slides. So, you get people into these roles, and then sometimes they go on vacation, and then you try to replicate the dropping that person can do because of their, unique experience in that area. It's a challenge. There's still a lot of voodoo. I mean, making good G-banded slides is it's a very challenging exercise when you consider all temperature, humidity, all these kinds of other considerations. Cecilia, there are a couple of questions for you just to finish. Having tested and decided not to adopt chromosome dropping, are you done considering this, or would you reconsider in the future? And I'll ask the second question after.
Yeah, I think I would reconsider in the future, just depending on seeing technology. I think I have to give it a little time because, the techs, they got sort of exhausted with trying automated dropping. So it'll probably be a little while before I circle back around.
Great. And another question here from the audience was, are your dropping conditioners standardized to make automated staining more consistent? Are you using thermotrons?
We use thermotrons.
Okay, great. Well, we are at 2:59. I think we've covered a lot of ground today. My head's spinning as the moderator, so I can only imagine what everybody else is feeling. I'd love to take this opportunity really to thank wholeheartedly Ninette, Jenny, and Cecilia for all of their time, sharing their expertise, for being willing to participate in this roundtable discussion and just a discussion of their experience. I think it's been a really fantastic opportunity for everybody to learn. There were so many questions from the Q&A that we just didn't have time to get to, and I apologize to all of you that answered questions. We'll have a look at the questions afterwards, and perhaps we'll be able to make something, make some kind of document later that we can send out to everybody that attended. But again, my appreciation to everybody. I have a couple of slides to share just to wrap up this session. So let me just switch back here. Okay. So thanks to everybody for attending. This is the code for PACE credit. If you are claiming PACE credit for this webinar as an accredited learning activity, so you need to use your code 97214. And finally, my slide will go forward. There we go. I want to remind everybody about the annual meeting. Our early registration ends on May 21st. If you've never been to a CGC meeting, I do highly recommend it. And I'm not saying that because I'm both on the Education Committee and the Board of Directors. I think it is a really great meeting. I've attended many times. So please attend if you can, either virtually or in person. And finally, our CGC Genomic Case Series is sponsored by the Cancer Genomics Consortium and the University of Wisconsin. So if you have interesting cases, take a picture here of that QR code, and that's how you can submit cases for any of the upcoming case series presentations. And we'd love to have your participation. And with that, I say thank you to everybody and good afternoon.